Welcome to the Podlets Podcast.
Hi, everybody. Welcome back to another episode of the Podlets. This is episode 12, and we're going to talk about distributed systems without a degree, or even with a degree, because who knows how much we learn in university. I am Calicia Campos, one of your hosts. Today, I also have Duffy Cooley. Say hi, Duffy.
Hey, everybody.
And a new host for you, and this is such a treat, Michael Gasch. Michael, please tell us a little bit of your background.
Hey everyone. Thanks, Calicia. Yeah, so I'm new to the show. Just want to keep it brief because I think over the show we'll discuss our backgrounds a little bit further. So right now I'm with VMware. So I've been with VMware almost for 5 years. And currently I'm in the office of the CTO. I'm a platform architect in the office of the CTO, and I mainly use Kubernetes on a daily basis from an engineering perspective. So we build a lot of prototypes based on customer input or ideas that we have, and we work with different engineering teams. So Kubernetes has become kind of my bread and butter, but lately more from a consumer perspective, like developing with Kubernetes or against Kubernetes instead of the former, where I've mostly been around implementing and architecting Kubernetes.
Nice. Very impressive. Duffy.
Thank you.
Yeah.
Let's give the audience a little bit of your background. We've done this before, but just to frame the episodes so people will know how we're coming at distributed systems.
Sure. So in my experience, I spent I don't have a formal education history. I've spent most of my time kind of like in a high school time, and then from there basically worked into different systems administration, network administration, network architect, on up into virtualization, and now containerization. So I've got a pretty hands-on kind of bootstrap experience around managing infrastructure, both at small scale inside of offices, all the way up to very large scale, working for some of the larger companies here in the Silicon Valley.
All right, my turn, I guess. So I do have a computer science degree, but I don't feel that I really went deep at all in distributed systems. And my degree is also from a long time ago. So mainly what I do know now is almost entirely from hands-on work experience. And I think I'm very much lacking. And I'm very interested in this episode because we're going to go through some great resources that I am also going to check out later. So let's get this party started.
Awesome. So you want to just talk about like kind of the general ideas behind distributed systems and like how you became introduced to them, or like where you started in that journey?
Yeah. Let's do that. I don't want to start though.
Yeah. So I guess for my first experience with the idea of distributed systems was in using them before I knew that they were distributed systems, right? Like one of the very first distributed systems, as I look back on it, that I ever actually spent any real time with was DNS. Which I consider to be something of a distributed system. If you think about it, they'll root name servers. You have a bunch of caching servers. You solve many of the same sorts of problems. And in a previous episode, we talked about how networking, just the general idea of networking and handling large scale and architecting networks, is also in a way has a lot of analogs into distributed systems. And so for me, I think like working with them and helping solve the problems that are associated with them over time gave me a good foundational understanding for when we were doing distributed systems as a thing later on in my career.
Yeah, you said something that caught my interest. It's very interesting because obviously for people who have been writing algorithms, writing papers about distributed systems, they're going to go yawning right now because I'm going to say the obvious. As you start your journey programming, you read for job requirements. You read, should know distributed systems, and you're like, oh, what is distributed system? What do they really mean? Because yes, we understand apps talk to apps, and then there is API, but there's always, for me at least, a question in the back of my head Is that all there is to it? It sounds like it should be a lot more involved and complex and complicated than just having an app talk to another app. And in fact, it is, because there are so many concepts and problems involved in distributed systems, right? Like from timing, clock, and sequence, and networking and failures. How do you recover? There is a whole world. How do you log things properly? How do you monitor? It's a whole world that revolves around this concept of systems residing in different places and needing to talk to each other.
I think you raise a very good point. It's like I think this is sort of like there's an analog to this in containers, oddly enough. Like when people say, I want a container, within container orchestration systems, they think that that's just a thing that you can ask for, that you get a container and inside of that's going to be your file system and it's going to do all the things. And in a way, I feel like that same confusion is definitely related to distributed systems. When people ask for, when people are interacting with distributed systems today, or if I were to ask like 50 people what a distributed system is, I would probably get 50 different answers, And I think that you've got a pretty concise definition there, in that it is a set of systems that intercommunicate to perform some function. Like it's fun at its baseline. I feel like that's a pretty reasonable definition of what distributed systems are, and then we can figure out, from there, like what functions are they trying to achieve, and what are some of the problems that we're trying to solve with them?
And that's what it's all about. From in my head is solving the problems, because at the beginning I was thinking, wow, it must be just about communicating and making things work. But it's the opposite of that. It's like that's a given. When a job says you need to understand about distributed systems, what they're really saying is you need to know how to deal with failures, not just make it work. Make it work is the sort of easy part, but the whole world of like where the failures can happen, how do you handle it, and that to me is what needing to know distributed system comes in handy. And it's completely different things. Like at the top layer, 5% is knowing how to make things work, and 95% is knowing how to handle things when they don't work, because it's inevitable.
Yeah, I agree. What do you think? What do you think, Michael? Like, how would you describe the context around distributed systems, and like what was the first one that you worked with?
Exactly. So, and it's kind of similar to your background, Duffy, which is no formal degree or education on computer science. Right after high school, jumping into my first job, working with computers, computer administration. I must say that from the age of, I think, 7 or so, I was interested in computers and all the stuff, but more from a hardware perspective, less from a software development perspective. So my take always was on disassembling the pieces and building my own computers, than writing programs. But in the early days, that just wasn't me. So I completely kind of almost missed the whole education and principles and fundamentals of how you would write a program for a single computer, and then obviously also for how to write programs that run across a network of computers. And so over time, as I progressed in my career, especially in the first job, which was 7 years of different Linux systems, Linux administrations, I kind of, like you, Duffy, I dealt with distributed systems without necessarily knowing that I'm dealing with distributed systems. I knew that it was mostly storage systems, Linux file servers, but distributed file servers, Samba, if some of you recall that project. So I knew that things could fail, a node could fail, for example, or a node could not be writable, and then so a client might be stuck. But not necessarily I did directly relate that to fundamentals of how distributed systems work or don't work. And over time, and this is really why I appreciate the Kubernetes project and community, I got more questions, especially when this whole container movement came up. I got so many questions around how does the thing work? How does scheduling work? Because scheduling kind of was close to my interest in hardware design, and low-level details. But I was looking at Kubernetes like, okay, there's the scheduler. And in the beginning, the documentation was pretty scarce around the implementation and all the controllers, what was going on. So I had to I listened to a lot of podcasts and Brian Grant's great talks and different shows that he gave from the Kubernetes space and other people there as well. But in the end, I had more questions than answers. So I had to dig deeper, and eventually that led me to a path of wanting to understand the more formal theory behind distributed systems, like reading the papers, reading books, taking some online classes, just to get the basic understanding of those issues. And so I got interested in resource scheduling in distributed systems and consensus. So those were two areas that kind of caught my eyes. Like, so what is it like? How do machines agree in a distributed system if so many things can go wrong? And maybe we're going to explore this later. So I'm going to park this for a bit. But back to your question, which was kind of a long-winded answer or road to answering your question, Duffy. For me, a distributed system is like this kind of coherent network of computer machines that from the outside to an end user or to another client looks like one gigantic big machine that is failure tolerant, that is fast, that is performing, also efficient. Like, it constitutes a lot of characteristics and properties that we want from our systems that a single machine usually can't handle, but it looks like it's a big single machine to a client.
I think that, it is interesting. Like, I don't want to get into, I guess this is probably not just a distributed systems talk, but like, obviously one of the questions that falls out for me when I hear that answer is, what is the difference between like a microservice architecture and distributed systems? Because I think it's, to your point, like the way that a lot of people work with to learn to develop software, it's like, we're going to develop a monolithic application just by nature, right? We're going to solve a software problem using code. And then later on, when we decide to actually like scale this thing or understand how to better operate it under a significant load, then we start thinking about, okay, well, how do we have to architect this differently in such a way that it can support that load? And that's where I feel like the beams kind of cross, right? Like, you're suddenly in a world where you're not only just talking about microservices, you're also talking about distributed systems, because you're going to start thinking about how to understand transactionality throughout that system, how to understand how, all of those consensus things that you're referring to, like, how do they affect it when I add Mr. Network in there, like, but that's cool. So
yeah, just one comment on this, Duffy, which took me a very long time to realize, which is coming like from my definition of what a distributed system is, like this group of machines that perform work in a certain sense, or maybe even more abstracted, like it's a bunch of computers networked together. What I kind of missed most of the time, and this goes back to the DNS example that you gave in the beginning, was that the client or the clients are also part of this distributed system, because they might have caches, especially in DNS. And so you always deal with this kind of state that is distributed everywhere. Maybe you don't even know where it kind of is distributed, and the client kind of works with the local stale data. So that is also part of your distributed system, and something I want to give credit to the Kafka community and some of the engineers on Kafka, because there was a great talk lately that I heard, and it's like, right, the client is also part of your distributed system, even though usually we think it's just the server, like those many server machines or those microservices. At least I missed that long time.
You should put a link to that talk in our Hackroom. That'd be awesome. Sounds great. So, what do you think, Alicia?
Well, one thing that I wanted to mention is that, so Michael was saying how he has been self-teaching distributed systems, and I think if we want to be competent in that area, we have to do that. And I'm saying this to myself even. It's very refreshing when you read a book or you read a paper and you really understand the fundamentals of an aspect of the distributed system, how a lot of things fall into place in your head. And I'm saying this because even prioritizing reading about and learning about the fundamentals is really hard for me, because you have your life, you have things to do, you have like the minutiae and things to get done. But so many times I struggle, and I is in the rare occasions where I go, okay, let me just learn this stuff instead of trial and error. It makes such a difference. And then once you learn, it stays with you forever. So it's really good. It's so refreshing to read a paper and understand things at a different level. And that's what this episode is. I don't know if this is the time to jump into the list of recommendations. I don't know how deep, Michael, you're going to go. You have a ton of things listed, and everything that we mentioned on everything we mentioned on the show is going to be on our website, on the show notes. So nobody needs to be necessarily taking notes. Oh, and another thing I wanted to say is it would be lovely if people would get back to us once you listen to this. Let us know if you want to add anything to this list. It would be awesome.
Right.
We can even add this list later and give a shout out to you. So it'd be great.
Right, and I don't want to cover this whole list. I just wanted to be as complete as possible by the stuff that I kind of read or watched, and so I just put it in, and I just pick some highlights there if you want.
Go for it.
Yeah. Okay. Perfect. So honestly, even though not the first on the list, but the first thing that I read, so maybe from kind of my history, how I approached things, was searching for like how do computers work and what are some of the issues and how do computers and machines agree. Obviously, the classic paper that I read was the Lamport paper, Time Clocks and the Ordering of Events in a Distributed System. And I want to be honest, like first time I read it, I didn't really get the full essence of the paper, because there's a proof in there, and so the mathematic proof for me didn't like click immediately. And there were so many things and concepts and physics and time and that were thrown at me, where I was looking for answers and I had more questions than answers. But this is not to Leslie. This is more like by the time I just wasn't prepared for the how deep the rabbit hole goes. And so I thought, if someone asks me if I only have time to read one book out of this huge list that I have there and all the other resources, which one would it be? Which one would I recommend? And I would recommend Designing Data-Intensive Apps by Martin Kleppmann, which I've been following his like blog posts and some partial releases he's done before fully releasing that book, which took him more than 4 years to release that book. And it's kind of almost the Bible, the state-of-the-art Bible when it comes to all concepts in distributed systems. Obviously consensus, network failures and all the stuff, but then also leading into modern data streaming, data platform architectures, inspired by, for example, LinkedIn and other communities. So that would be the book that I would recommend to someone if he would just have time to read one book.
That's a neat approach. I like the idea of if you had one way to help somebody ramp on distributed systems and stuff, what would it be? For me, it's actually, I don't think I would recommend a book, oddly enough. Like I feel like I would actually I'd probably drive them toward the Kind project, like the kind.sigs.kh.io project, and say, this is a distributed system all by itself. Start tearing apart the pieces and seeing how they work and breaking them and like exploring and like kind of just playing with the parts. Like you can do a lot of really interesting things. And there's actually another book in your list that was written by Brendan Burns about like designing distributed systems.
Yes,
I think it's called. And that book, I think he actually uses Kubernetes as a model for how to go about achieving these things, which I think is incredibly valuable because it really gets into some of the more stable design distributed systems patterns that are around. And I feel like that's a great entry point. So if I had one thing, if I had to pick one way to help somebody or to push somebody in the direction of trying to learn distributed systems, I would say, identify those distributed systems that maybe you're already aware of and really explore how they work. and like what the problems with them are, and like and how they went about solving those problems. Like really dig into the idea of it. Like get something you can put your hands on and play with. Like, I mean, Kubernetes is a great example of this, and this is actually why I referred to Kind.
Right.
Yeah, the way that it works for me when I'm learning something like that is to really think about what the boundaries are, what the limitations are, what the trade-offs are. And if you can take a smaller system, maybe something like the Kind project, and identify what those things are. And if you can't, then ask around, ask someone, Google it, I don't know. And maybe it'll be a good episode topic for us to do that.
Right.
This part is doing this, map things out. So maybe we can understand better and help people understand things better. So mainly let's identify what the distributed system pieces are. But for people who don't even know what they could be, it's harder to identify. I don't know what a good strategy for that would be. Because you can read about distributed systems, and then you can go and look at a project, and how do you map the concepts you're learning to what you're seeing in the code base? For me, that's the hardest thing.
Exactly, and something that I had related experience was like when I went into software development, without having formal education on algorithms and data structures. Sometimes in your head, you have the problem statement and you're like, okay, I would do it like that. But you don't know the word that describes, for example, a heap structure or a queue. Because you've never someone told you that is a heap, that is a queue, and that is a stack.
Exactly.
And so for me, reading that book was a bit easier. Like, even though I have done distributed systems, if you will, administration many years ago, I didn't realize that it was a distributed system because I never had this definition, or I never had those failure scenarios that in mind, and I never had a word for consensus. So how would I search for something like how do machines agree? I mean, if you put that on Google, then likely there will come up a lot of stuff. But if you put in a consensus algorithm, then likely you get a good hit on what the answer should be.
And it's really problematic when we don't know the names of things, because and what you said is so right, because we are probably doing a lot of distributed systems without even knowing that that's what it is. And then we go in the job interview and people are, have you done a distributed system? No.
Yeah, exactly.
But you just don't know how to name things.
Yeah,
but
exactly.
That's one. Yeah, right. That's one issue. Another issue, which is a bigger issue though, is at least that's how it is for me. I don't want to speak for anybody else, but for me, it's definitely, if I can't name things and I face a problem and I solve it, every time I face that problem, it's a one-off thing, because I can't map to a higher concept. So every time I face that problem, it's like, oh, it's not like, oh yeah, this is this kind of problem. I have a pattern. I'm going to use that to this problem. So that's what I'm saying. Once you learn the concept, but you need to be able to name it. And then you can map that concept to problems you have. All of a sudden, if you have like 3 things on the tool belt you can use to solve those problems, because as you work with computers and coding, it's like you see the same thing over and over again. But when you don't understand the fundamentals, things are just like it's a bunch of different one-offs. It's like when you have an argument with your spouse or girlfriend or boyfriend. Sometimes it's like you arguing like 10 times in a month, and you thought, oh, I had 10 arguments. But if you stop and think about it, no, we had one argument 10 times. It's very different than having, 10 problems versus having one problem 10 times, if that makes sense.
I think it does. Right?
Yeah.
Oh, sorry.
No, go. Yeah, get it. I just wanted to agree.
Yeah, I think it does make sense. I think it's interesting. Like you've highlighted it, kind of an interesting a pattern, around the way people learn, which I think is really interesting. And that is that, like, some people are able to read about patterns or software patterns or algorithms or architectures and have that suddenly be an index in their head. Like they can actually then later on correlate what they've read with the experience that they're having around the thing that they're working on. For some, it needs to be hands-on. They need to actually be able to explore that idea and understand and manipulate it and be able to describe how it works or functions, in person, in reality. Like they need to have that hands-on, like I need to touch it to understand it kind of experience. And those people also, as they go through those experiences, start building this index of patterns or algorithms in their head. They have this thing that they can correlate to, right? Like, oh, this is a time problem, right? Or, oh, this is a consensus problem, or what have you, right?
Exactly.
And you may not know the word for that thing, but you're still going to develop a pattern in your mind, like the ability to correlate this particular problem with some pattern that you've seen before. What's interesting is, like, I feel like people take different approaches to building that index, right? Like for me, it's been troubleshooting. Somebody gives me a hard problem and I dig into it and I figure out what the problem is, regardless of whether it's like, to do with distributed systems or cooking, like it could be anything, but like, I always want to like get right in there and figure out what that problem is and like start building a map in my mind of like all of the players that are involved, And for others, I feel like, with an educational background, like if you have an education background, I think that sometimes you end up coming to this with a set of patterns already instilled that you understand, and you're just trying to apply those patterns to the experience you're having instead, which is it's like horse before the cart or cart before the horse. It's very interesting when you think about it,
Yes.
Yeah. And the recommendation that I just want to give to people that are like me, who like reading, is that I went overboard a bit in the beginnings because I was so fascinated by all the stuff, and I went down the rabbit hole deeper, reading and reading and reading. And at some point, even coming to weird YouTube channels that talk about, like, is time real and where does time emerge from? Like it became philosophical, even like to pass where I went to. Now, the thing is, and this is why I like Duffy's approach with like breaking things and then trying to break things and understanding by how they work and how they can fail, is that immediately you practice, you're hands-on. And so that would be my advice to people who are more like me, who are fascinated by reading and all the theory, that your brain and your mind is not really capable of kind of absorbing all the stuff and then remembering without practicing. And practicing can be breaking things or installing things or administrating things or even writing software. But for me, that was also a late realization that I should have maybe started doing things earlier than at the time I spent on reading.
By doing, you mean like hands-on?
Yeah.
Anything specific that you would have started with?
Yeah, so on Kubernetes, so going back those 15 years to my early days of Linux and Samba, which is a project, by the time I think that it was written in C or C++, but the problem was I wasn't able to read the code. So the only thing that I had by then was some mailing lists and asking questions and not even really knowing which questions to ask because of the lack of words of understanding. Now, fast forward into Kubernetes time, which got me like deeper in distributed systems. I still couldn't read the code, like because I didn't know Go, but I forced myself to read the code, which helped a little bit for myself to understand what was going on, because the documentation by then was lacking. These days it's easier because you can just install FireUp kind. Way easier today. The hands-on piece, I mean.
You said something interesting, Michael, and I've given this advice before because I use this practice all the time, and it's so important to have a vocabulary. It's like you just said, I didn't know what to ask because I didn't know the words.
Yeah.
And to people, and I practice this all the time, to people who are in this position of distributed systems or whatever it is, or something more specific that you are trying to learn, try to expose yourself to the words, because our brains are amazing. And once you get exposure, it's like your brain works in the background, and all of a sudden you go, oh yeah, I know this word. So podcasts are great for me. It's like if I don't know something, I'll look for a podcast on the subject and I start listening to it. And as the words get repeated, just contextually, I don't have to go and get a degree in a thing. Just by listening to the words being spoken in context, I start absorbing the meaning of it. So podcasting is great, or YouTube, or anything that you can listen, in reading too, of course. Or the best thing is talking to people. But again, it's really, sometimes it's not trivial to put yourself in positions where people are discussing these things. So
I think that some of the, there are actually a number of meetups here in the Bay Area, and there's a number of meetups. That whole meetup thing is sort of nationwide across the entire U.S. and around the world, it seems like now lately. And those meetups, I feel like there are a number of meetups in different subject areas. Like there's one here in the Bay Area called Papers We Love, where they actually do explore, like, interesting technical papers, which are obviously a great place to learn the words for things, right? Like, because this is actually where those words are being defined, right? Like when you get into, the consensus stuff, like they really get into like what even is Raft. There are many papers on Raft and many papers on multiple things that get into consensus. And so, like, definitely, whether you explore a meetup on a distributed system or on a particular application or on a particular theme like Kubernetes, like those things are great places just to kind of, get more exposure to what people are thinking about in those problems.
That is such a great tip.
And the podcast advice is good as well, because for people, non-native English speaker, people, not speakers, people. The thing is that the word you're looking for might be totally different than the English word. And like, for example, consensus in Germany has like totally different meanings. So if I would look that up in German, likely I would find nothing or not really related to it at all. So you have to go through translation and then finding this stuff. And so what you said, Carlissia, or Duffy with the PWL, the Papers We Love, or podcasts, those words, like often they are in English, those podcasts, and they are natural, like consensus or sharding or partitioning. And those are the words then that you can at least look up. Like, what does it mean? And that's what I did as well. That's right.
Yes. And I also wanted to do a +1 for Papers We Love. They're everywhere. And they also have an online they have an online version of the Papers We Love meetup. And a lot of the local ones film their meetups. So you can go through the history and see if they talked about any paper that you're interested in. And probably, I'm sure multiple locations talk about the same paper, so you can get different takes too. It's really, really cool. Sometimes it's completely obscure, like I didn't get a word of what they were saying, like not one. What am I doing here? But sometimes they talk about things, you at least know what the thing is, and you get like 10% of it. But some people, people who deal with papers day in and day out, it's very much, I don't know.
It's super easy. It's super easy when, like, when going through a paper like that, to like have the imposter syndrome wash over you, right? Because you're like,
thank you. That's what I wanted to say.
I feel like I've been in this for 20 years. I probably know a few things, right? But at the same time, I'm reading this consensus paper going, can I buy a vowel? Like, what is happening?
Yeah, can I buy a vowel? Is great. That's awesome, Duffy.
But the other piece I want to call out to your point, which I think is important, is that, like, some people don't want to like go out and be there in person. They don't feel comfortable or safe exploring those things in person. Yeah. And so there are tons of resources, like you just pointed out, like the online version of Papers We Love. You can also sign into Slacks and just interact with people via text messaging, right? Like there's a lot of really great resources out there for people of all types, including the amount of time that you have.
And for Papers We Love is like going to a language class. If you go and take a class in Italian, your first day, even though it's going to be super basic, you're going to be like, what? And you go back, and your third week, you start, oh, I'm getting this. And then a month, 3 months, oh, I'm starting to be competent. So you go once, you're going to feel lost and huge imposter syndrome, but you keep going because there is a format. So if you start absorbing what the format is, and that helps you understand the content. So once your mind absorbs the format, you're like, okay, now I know how to navigate this. I know what's coming next. So you don't have to focus on that. You start focusing on content. And then, little by little, you become more proficient in understanding. Mm-hmm. And pretty soon you're going to be wanting to write a paper. Hasn't happened. I'm not there yet.
That's awesome.
At least that's how I think it goes. I don't know.
I agree.
It's also changed over time. It's fascinating if you read papers from like 20 years ago and you read papers that are written more recently. It's interesting, like the papers have changed their language when considering competition. Like when you're introducing a new idea with a paper, frequently like that you're introducing it into a market full of competition, you're being very careful about the language, almost in a way to complicate the idea rather than to make it clear. Which is challenging. Like there are definitely some papers that I've read where I was like, why are you using so many words to describe this simple idea? Right? Like it makes no sense. But yeah.
One thing that I don't want to make this episode all about papers we love, but it was so good that you mentioned that, Tuffy. It's really good to be in a room, or watching something online where you see people asking questions and people go, oh, why is this thing like this? Like, why is X like this? Or why is Y done like this? And then you go, oh, I didn't even think that X was important. I didn't even know that Y was important. So you start picking up like what the important things are. And that's what makes it click, because now you like hooking into the important concepts, because people who know more than you are pointing out and asking questions, and so you start paying attention to learning what the main things you should be paying attention to are, which is different from reading the paper by yourself. It's like just a ton of text content that you need to sort through.
Yeah, I frequently self-describe as a perspective junkie, because I feel like for any of us really to learn more about a subject that we feel we understand, we need the perspective of others to really engage, to expand our understanding of that thing, right? Like I feel like I know how to make a peanut butter and jelly sandwich. I've done it a million times. It's like it's a solid thing. But then I watch my kid do it, and I'm like, I hadn't thought of that problem, like that was so long ago, right? And this is a great example of that. Like those communities, like Papers We Love, are a great opportunity to understand the perspective of others around these hard ideas. And when we're trying to understand complex things like distributed systems, this is where it's at. Like this is actually how we go about achieving this. There is a lot that you can do on your own, but there is always going to be more that you can do together, right? Like you can always do more. You can always understand this idea faster. You can understand the complexity of a system and how to break it down into these things by exploring it with other people. And
that is so well said. And it's the reason for the show to exist, right? Because we come on the show and we give our perspectives, and people get to learn from people with different backgrounds, what their takes are on distributed systems, cloud native. So this was such a major plug for the show. Keep coming back. You're going to learn a ton. And also, it was funny that it was the second time you mentioned cooking, made a cooking reference, Tuffy, which brings me to something I want to make sure I say on this episode. I added a few things for reference for 3 books, but the one that I definitely would recommend starting with is The Systems Bible by John Gall. And this book is so cool because it helps you see everything through systems. It's like everything is a system. A conversation can be a system, like an interaction between 2 people can be a system. I'm not saying this book says that, it's just like my translation. And like you can look, cooking is a system. There's a process, there is a sequence. So it's really, really cool. And it really helps to have things framed in this way and then go out there and read the other books on systems, I think it helps a lot. This is definitely what I am starting with and what I would recommend people start with, the Systems Bible. Did you know this book?
I did not.
I'm not aware of it either. Although I really appreciate the idea. Like I do think that that's true. Like if you develop a skill for understanding systems as they are, then you're basically frequently what you're developing is the ability to recognize patterns, right?
Exactly.
You can recognize those patterns in anything. Like
yeah, and that's a good segue for just something that came to my mind. So recently I gave a talk on event-driven architectures, and for someone who's not like a software developer or architect, it can be really hard to grow like this whole like all those concepts on asynchrony and eventual consistency and idempotency. Like there's so many words that like what is this all like, sounds weird, way too complex. But I was reading a book some years ago by Gregor Holpe, and he's the guy behind Enterprise Integration Patterns as well, also a book that I have on the list here. And he said your barista doesn't use two-phase commit. And so he was basically making this analogy of, he was in a coffee shop and he was just looking at the process of how the barista makes the coffee. Like you pay for it and like all the things that can go wrong while your coffee is brewed and served to you. And so he was making this relation between the real world and the life and human society to computer systems. And there it clicked to me, whereas like so many problems we solve every day, for example, agreeing on a time where we should meet for dinner or cooking, is a consensus problem, and we solve it. Like we even solve it in the case of failure. Like I might not be able to call Duffy because he's not available right now, and so somehow we figure out.
Yeah.
And I always thought that those problems just exist in computer science and distributed systems, but I realized actually that's just a subset of the real world as is. And
Absolutely.
Looking at those problems from through the lens of your daily life, when you get up and all the stuff, there's so many things that are related to computer systems.
Michael, I missed, was it an article you read?
Yes, I need to put that in there as well. Yeah,
please put that in there. And absolutely. So I'm so far from being any kind of expert in distributed systems, but I have noticed, I have caught myself using not distributed systems, but systems thinking for even complicated conversations, even like in my personal life. I started approaching things in a systems oriented, and just a high level example. When I am working with systems, I can approach from, the beginning, the end. It's like a puzzle, putting the puzzle together, right? Sometimes you start from the middle, sometimes you start from the edges. And when I'm having conversations that I need to be very strategic, and like I have one shot, let's say maybe I'm in a school meeting and I have to reach a consensus or have a solution or have a plan of action, and I have to ask the right questions. And my prior self would do things linearly, like historically, like let's go from the beginning and work out to the end. And now I don't do that anymore. Not necessarily. Sometimes I'm like, let me maybe ask the last question I would ask and see where it leads, and just like approach things from a different way. I don't know if this is making sense.
It does.
But my thinking has changed. The way I see the possibilities is not a linear thing anymore. Like I see how you can totally switch things. And I use this in programming a lot. Like, or in also writing. Sometimes you, like when you're a beginner writer, you start at the top and you go down to the conclusion. And sometimes I start in the middle and go up, right? So you can start anywhere. It's beautiful. It just gives you so much more options, so many more options. Anyway.
I got that. Oh, Duffy wanted to say something.
Or maybe I'm just crazy. Don't listen to me.
I don't think you're crazy. I was going to say one of the funny things about Michael's point and your point both, it's like in a way that they kind of refer to like Conway's law, the idea that like people will build systems in the way that they communicate. And so this is actually, it totally brings it back to that point of thing, right? Like we by nature will build systems that we can understand, because is the constraint in which we have to work, right? And so it's very interesting.
Yeah, but it's an interesting thing because like we are also influenced by the way we are forced to work. For example, I work with constraints. And what I'm saying is that has been influencing my way of thinking. So yes, I built systems in the way I think, but also because of the constraints that I'm dealing with, that I have to be, like the trade-offs I need to make, that also turns around and influences the way I think, the way I see the world, the rest of the systems in all the rest of the world. And of course, as I change my thinking, possibly you can theorize that you go back and apply things that you learn outside of your work back to your work. It's a beautiful back and forth, I think.
I had the same experience with when I had to design kind of my first API and think of, okay, what would the consumer contract be, and what would a consumer expect me to deliver and response and so on. I was forcing myself and being explicit in communicating, and like not throwing everything at the client back to confuse him, but being very explicit and precise. And also in communication on every day, when you talk to people, being explicit and precise really helps to avoid a lot of problems and trouble, be it in your partnership or amongst friends or at work. Like, this is what I took from computer science actually back into my real world, in order to like taking others' perceptions, perceiving things from a different perspective, and being more precise and explicit in how I respond or communicate.
My take on what you just said, Michael, is we design systems thinking, how is this going to fail? We know it's going to fail. We're going to design for that. We're going to implement for that. In real life, for example, if I need to get an agreement from someone, I try to understand that person's thinking and go, I just had this huge thing this week, so that's what this is in my mind. I'm not constantly thinking about this. I'm not crazy like that. Just a little bit crazy. It's like, how does this person think? What do they need to know? How far can I push, right? Because we need to make a decision quickly. So the approach is everything, and sometimes you only get one shot. So yeah, I mean, correct me if I'm wrong. That's how I interpreted what you just said.
Yeah, absolutely, spot on. So I'm not crazy as well. At least
so basically, I think what we ended up turning this episode into is a little bit of like, here are great references, and also a huge endorsement for really going deep into distributed systems, because it's going to be good for your job, it's going to be good for your life, it's going to be good for your health. We are crazy.
I'm definitely crazy. You guys might not be, but I'm nuts. All right. So we started this episode with the idea of coming to learning distributed systems, perhaps without a degree or without a formal education in it. And we've talked about like a variety of different ideas on that subject, like different approaches that we each of us took, like how we each of us see the problem. Is there any important point that either of you want to throw back into the mix here or bring up in relation to that?
Well, what I take from this episode, being my first episode and getting to know your background, Duffy and Kalisya, is that whoever is going to listen to this episode, whatever background you have, even though you might not be in computer like systems or industry at all, I think we three are the proof that whatever background you have, if you're just curious a little bit and maybe a little bit crazy, you can totally get down the rabbit hole into distributed systems and get totally excited about it. There's no need for having formal education and a degree to enter this world. It might help, but it's kind of not a high bar that I was perceiving it to be 10 years ago, for example.
Yeah, that's a good point. And my takeaway is, it always puzzled me how some people are so good and experienced and such experts in distributed systems. And I always look at myself like, how am I lacking that? Like, what memo did I miss? What class did I miss? Like, what project did I not work on to get that experience? And what I'm seeing is you just need to put yourself in that place. You need to do the work. But the good news is achieving competency in distributed systems is doable.
Right. Well
Yeah.
said.
And my takeaway is as we discussed before, I think that, there is no one thing that comprises a distributed system. It is a number of things, right? Like it is basically a number of behaviors or patterns that we see that comprise what a distributed system is. So when I hear people say, I'm not an expert in distributed systems, I think, well, perhaps you are, and you maybe don't know it already. Like maybe there's some particular set of patterns with which you are incredibly familiar. Like you understand DNS better than the other 20 people in the room.
Yeah.
That exposes you to a set of patterns that certainly give you the capability of saying that you are an expert in that particular set of patterns, right? Like, and so I think that to both of your points, it's like you can enter this stage where you want to learn about distributed systems from pretty much any direction. You can learn at it from a CIS background. You can come to it like with no computer experience whatsoever, and it'll obviously take a bit more work. But like, this is really just about developing an understanding around how these things communicate and the patterns with which they accomplish that communication. And I think that's the important part.
Yeah.
Great.
Is this a wrap?
Yeah.
Sounds like.
Okay.
I loved this episode.
Yeah.
I'm really hoping you'll be useful for people.
Me too.
All right, everybody. Thank you, Michael Gasch, for being with us now. Hope to see you in more episodes. I know we will. Thank you, Duffy.
My pleasure.
And again, I'm Carlisia Campos. With us was Duffy Cooley, Michael Gasch. This was episode 12. And I hope to see you next time. Bye.
Bye.